Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor from Aero Education Network, and today I'm going to solve some questions from A-level mathematics, AS Pure Mathematics 1, Cambridge 9709. The topic is functions. Overall, this lecture is, for the past paper practice of the topic functions. Particularly, I'm going to be dealing with, domain and range of composite functions as well and inverse functions as well. So first of all, we have question number 30, which is October-November 2017, paper 1, variant 1, question number 9. So it says that the functions f and g are defined for x is greater than 3 by fx is equals to 1 over x square minus 9 and gx is equals to 2x minus 3. Both of the functions f and g have a restricted domain, which is x is greater than 3. The requirement of part 1 is to find and simplify an expression for g of gx, meaning, the function g is acting twice, meaning g square x. Okay, so first thing first, we have a linear function gx, which is 2x minus 3. So g of gx means that input of the gx function is now gx itself. So we are going to say that g of gx is equals to 2 times 2x minus 3 and then minus 3. All right. So g of gx is basically 4x minus 6 minus 3, which is supposed to be 4x minus 9. This is the composite function as per the requirement g of gx. Okay. So here we have part 1. Now in part 2, it says that find an expression for f inverse x and state the domain of f inverse. So here we need to find the f inverse x function first. Okay, so first of all, we will keep y is equals to fx. So y is equals to 1 divided by x square minus 9. Okay, so this means that x square minus 9 is equals to 1 over y. We are going to make x the subject. Okay, so x square will be equals to 1 over y plus 9. Now taking square root on both sides, so x will be equals to plus minus under root of 1 over y plus 9. So far we have achieved this thing. So now in place of x, I'm going to write f inverse x, and in place of y, I'm going to write x. However, we would need to consider that either we need to keep the plus sign over here or the minus sign over here before the under root. And for that purpose, we are going to observe what is the range of f inverse x. Okay, since we have seen that, the domain of fx is that x is greater than 3. Okay, so we are going to say that the domain of, fx will become the range of f inverse, as we know the fact that domain of fx will become the range of f inverse x. Okay, so since the domain of fx is that x is greater than 3, so the range of f inverse x would be f inverse x is greater than 3. Agreed. So we need the outputs of f inverse x to be greater than 3. And that would be only possible if the positive sign is over here. Okay. However, when you have a positive square root, it is such an obvious thing over here that you don't need to mention the positive sign over here. Meaning, I'm trying to say that, let's say, if you have x is equals to under root of 3, so here it is a very obvious thing that x is basically the positive square root. Okay, so we don't need to mention this very obvious thing over here. So therefore, we are going to say that f inverse x is equals to under root of 1 upon x plus 9. As simple as that. This is supposed to be your answer, the f inverse x function. And here we also need to state the domain of f inverse as per the requirement of the question. Okay, So what we are going to say that, in order to find the domain of f inverse, first of all, we have to find the range of fx. Since we know the fact that the domain, the domain of f inverse x is basically the range of fx. And in order to find the range of any function, always helpful to sketch the graph. So first of all, I'm going to give some detailed explanation over here regarding, sketching the fx function over here. Okay, so fx is basically 1 divided by x square minus 9. So if we don't have any restriction on the domain of the function fx, first of all, we are going to consider how to sketch the function over here without any restriction on the domain. First thing first, what you can see that if the denominator of this function is equal to 0, so the function will be undefined, isn't it? So if x square minus 9 is kept equal to 0, so x squared is equals to 9 and x is equals to plus minus 3. Okay, so this essentially means that, x is equals to 3 and x is equals to minus 3 are the vertical asymptotes over here. So I'm going to make the vertical asymptotes. Okay, first of all, I'm sketching the graph without any restriction on the domain. And then according to the domain of the question, I'm going to sketch the graph. So x is equals to 3 and x is equals to minus 3 are the two vertical asymptotes over here. All right. And the second thing is that if you want to see what is the horizontal asymptote, so when output of the function is kept equal to 0, when fx is basically kept equal to 0, so 1 upon x square minus 9 will be equal to 0, which means that x square minus 9 will be equals to 1 divided by 0, meaning x will be undefined. Okay, so x is undefined because you kept output of the function is equal to 0, meaning y is kept equal to 0, as we are sketching the graph of y is equals to fx. This means that x-axis is the horizontal asymptote. The line of y is equal to 0 would be a horizontal asymptote over here. Okay, and now if I keep the input of the function x is equal to 0, so the output will be 1 divided by minus 9, which is minus 1 over 9. Okay, when input of the function is x is equal to 0, so output is minus 1 over 9. All right, and by keeping the units on the scale of the y-axis to be very small, and by considering the asymptotes, what I'm going to do, I'm going to sketch the graph of fx. So, this would look something like this. The sketch of the graph would be, symmetrical about the y-axis. All right. And the rule for the asymptotic graph is that on a particular infinity, the graph is approaching. So the graph is continued from the opposite infinity. If I explain this thing in Urdu, तो जिस infinity पे आपका ग्राफ जो है वो लाइक अप्रोच कर रहा है, उसकी ऑपोजिट इन्फिनिटी से फिर ये कंटिन्यू होता है. यानी कि यूं समझें कि जिस इन्फिनिटी पे एंड होते हैं उसकी ऑपोजिट इन्फिनिटी से स्टार्ट होते हैं. ओके, सो द ग्राफ वुड कंटिन्यू something like this after the asymptote, and make sure that x-axis is the asymptote as we have seen. All right, and before x is equals to minus 3, the graph would look something like this. So this is basically the sketch of the fx function without any restriction on the domain. All right, and how do I know that the graph is exactly symmetrical about the y-axis? Let's say if you keep x is equals to 1 over here. Okay, if you keep x is equals to 1 over here, so let's see what is the output of the function. This will be 1 divided by 1 square minus 9, which will be minus 1 over 8. Isn't it? Makes sense? I'm just trying to give some detailed explanation regarding the sketching of this function. And in the same way, if you keep the input of the function as x is equals to minus 1, okay, so you will get the same output, because you know when -1 is squared, it will give you 1. And when you keep input of the function as x is equals to -1, so the output will be the same, -1/8. So this thing is basically an evidence that the graph is symmetrical about the line y-axis. However, in this case, in this question, we have a restricted domain. Okay, so this complete explanation was uh, in enough detail. I just want to give you some detailed explanation about the sketching of this particular graph. बस मेरा दिल कर रहा था कि भाई डिटेल में एक्सप्लेनेशन यहाँ पे दी जाए. Okay, so however, what you can see over here that the domain of the function is that x is greater than 3. So what I'm going to do, I'm going to just keep this part of the graph and the remaining part would be erased now. Okay, so I'm just going to keep the graph for the domain x is greater than 3 and all of the remaining part would be erased. All right. And as we have already seen that x is equals to 3 is a vertical asymptote. Okay, so this is basically the graph as per the requirement of the domain. Okay, so as we can see that the graph is above the horizontal asymptote, complete graph is above the horizontal asymptote, meaning it is above the x-axis. So therefore, I'm going to say that fx is greater than 0. All right, or you can say y is greater than 0. As you already know that the range can be also given in form of y. Okay, so therefore, this thing is basically the range of the function. Either you can write fx is greater than 0 or you can write y is greater than 0. This is the range of the function fx, which will essentially become the domain of the f inverse x function. Therefore, we are going to say that the domain of f inverse x is that x is greater than 0. This is supposed to be your answer. So I've given some detailed explanation over here regarding the sketch of this particular graph. So this was a requirement of part 2. So now we have part 3, which says that solve the equation f(g(x) is equals to 1 over 7. Okay, so I'm going to solve this part 3 over here. I'll make a separator. Okay, so we need to solve this equation f(g(x) is equals to 1 over 7. So first of all, as we can see that the fx function is 1 divided by x square minus 9. Okay, so now we need to make a composite function over here and we need to solve this equation. So f(g(x) would be something like this, that input of the fx function is now the gx function itself. So therefore I'm going to say that 1 upon gx square minus 9. Okay, which means that in place of x, I'm going to substitute the gx function, which is 2x minus 3. So this becomes 1 upon 2x minus 3 whole square minus 9 is equals to 1 over 7. And now in the next step, I'm going to do cross multiplication over here. So 7 is equals to 2x minus 3 whole square minus 9. So therefore, I'm going to say that 2x minus 3 whole square is equals to 7 plus 9, which is supposed to be 16. So this is basically a straightforward completing square form. Okay, so I can say that taking square root on both sides, 2x minus 3 will be equals to plus minus 4. So either 2x minus 3 is equals to 4, meaning x is equals to 4 plus 3 completely divided by 2, meaning x is equals to 7 over 2. And the other possibility is that 2x minus 3 is equals to minus 4. So x is equals to minus 4 plus 3 completely divided by 2, meaning x is equals to minus half. However, whenever solving the equations involving composite functions, we always need to consider the domain of the inner function. In the case of f gx, we can see that the inner function is gx, okay? And the domain of the inner function is x is greater than 3. In this particular question, both of the functions f and g are having the domain x is greater than 3. However, we are concerned right now with the domain of the inner function. So x is greater than 3, meaning the answers which are according to the domain of the inner function, those will be acceptable only. Okay, so let's say, you know, if I make a sketch over here like this, let's say I have a value 3. So if I say x is greater than 3, so this means something like this. Arrow is moving towards the right. So as we can see that one value is x is equal to 7 over 2, which is 3.5. Let us somewhere over here. And the other value is minus half, let us somewhere over here. So the answer which will be acceptable is the one which is according to the domain of the inner function. So only x is equal to 7 over 2 will be acceptable and minus half will be rejected, since this is according to the domain of the inner function. So x is equal to minus half will be simply rejected, and your only answer is x is equal to 7 over 2. Therefore, x is equal to 7 over 2 is your only acceptable answer. Whenever we are solving equations related to the composite functions, we always need to consider the domain of the inner function. If the inner function is not having any restrictions on the domain, so both answers would be acceptable. However, in this case, only those answers would be acceptable which are according to the restricted domain that x is greater than 3. Therefore, x is equal to 7 over 2, meaning x is equal to 3.5 is your only acceptable answer. All right. So here is the complete solution for this question. October-November 2017, paper 1, variant 1, question number 9. So now let's move on to the next question, which is handout question number 32, October-November 2017, paper 1, variant 3, question number 6. So the question says that the functions f and g are defined by fx is equals to 2 divided by x square minus 1 for the domain x is less than minus 1, and gx is equals to x square plus 1 for the domain x is greater than 0. In part 1, we need to find an expression for f inverse x. So we need to find the f inverse x function. So first step would be we will keep y is equals to fx, meaning y will be equals to 2 divided by x square minus 1. Okay, so therefore we are going to say that x square minus 1 will be equals to 2 divided by y. So this means that x square is equals to 2 over y and then plus 1. So this means that when we take a square root on both sides, so x is equals to plus minus under root of 2 over y plus 1. So now in place of x, I'm going to write f inverse, and in place of y, I'm going to write x, but the sign which is before the square root, which can either be positive or negative, I need to pick one sign, one of them. Okay, so in place of x, I'm going to write f inverse x, and for the sign, either positive one or the negative one, I'll leave some space first. So f inverse x is equals to under root of 2 over x and then plus 1. And now I'm going to observe the range of the f inverse x function. And for that purpose, we will consider the domain of fx. As we know the fact that the domain of the function fx is that x is less than minus 1. X is below minus 1. So this thing will become the range of f inverse x. So we are going to say that f inverse x is below minus 1. Okay, so in order to make sure that your outputs of the f inverse x function are below minus 1, So obviously you need a minus sign over here before the square root. So therefore you can say that f inverse x is equals to minus under root of 2 over x plus 1. Okay, you can leave your answer in this form as well, or you can simply express this 2 over x plus 1 as a single fraction by taking the LCM. Okay, so this will become 2 plus x completely over x. So your equivalent form of f inverse x function is this as well. F inverse x is equals to minus sign is multiplied by under root of 2 plus x completely over x. Either you can write your answer in this form or this form. Okay, so this was the f inverse x function. This was the requirement of part 1. Alright, so now let's move on to part 2. The requirement is to solve the equation g of fx is equals to 5. Okay, so first of all, we need to find the composite function g of fx. Okay, so as we know that gx function is given to us x square plus 1. Okay, so now input of the gx function will be fx itself. So the input for g function will become fx itself, meaning fx is whole squared and then plus 1. So fx itself is 2 over x square minus 1. So 2 over x square minus 1 whole squared plus 1. This is your g of fx function. And we need to solve the equation g of fx is equals to 5. Okay, so this means that 2 over x square minus 1 whole squared plus 1 is equals to 5. Okay, so 4 divided by x square minus 1 whole squared is equals to 5 minus 1, which is equals to 4. So this means that x square minus 1 whole squared is equals to 4 over 4, which is supposed to be 1. So this means x square minus 1 is equals to plus minus 1. Okay, so this means x square minus 1 is either equals to 1. So x square is equals to 2. And the other possibility would be x square minus 1 is equals to minus 1, meaning x square is equals to minus 1 plus 1, which is 0, which means x is equals to 0 by taking square root on both sides. And in the case where x square was equals to 2, so x is equals to plus minus under root of 2. Okay, we have three values. X is equals to positive root 2, x is equals to negative root 2, and x is equal to 0. However, we need to consider the domain of the inner function. So inner function is basically fx, and the domain for the inner function is that x is below minus 1. So our answers would be according to this domain of the inner function, x is below minus 1. Okay, so for that purpose, I'll make a sketch over here. Okay, let's say this value is minus 1. So x being below minus 1 means the inequality would look something like this. Okay, so as per the equation which we have solved, one value is x is equals to under root of 2, let's say somewhere over here, and the other one is x is equals to minus under root of 2, which will be over here, and x is equals to 0. These are the three values which we have obtained. So according to the domain of the inner function, only one value is acceptable because x is below minus 1. Okay, the domain of the inner function is that x is below minus 1. So this means that x is equals to 0. This means that x is equals to 0 and x is equals to under root of 2 will be rejected. These two values are going to be rejected because these are not according to the domain of the inner function fx. So therefore, x is equals to minus under root 2 is your only acceptable answer. This is basically according to the domain of the inner function fx. Okay, all values would not be acceptable whenever we are solving, the equations which are related with composite functions. So we need to consider the domain of the inner function always. Okay, so x is equals to minus under root 2 is your only acceptable answer. All right, so this was question number 32 of the handout, October-November 2017, paper 1 variant 3, question number 6. All right, so now moving on to the next question. This is handout question number 33, February-March 2018, paper 1 variant 2, question number 10. The question says that functions f and g are defined by fx is equals to 8 over x minus 2 plus 2 for the domain x is greater than 2, and gx is equals to 8 over x minus 2 plus 2, meaning fx and gx are same functions. However, the domain for the gx function is that x is greater than 2 and less than 4. So the requirement of part 1, part A is to state the range of the function f. Okay, so as we know the fact that in order to find the range of any function, always helpful to sketch the graph. Okay, so I'm going to sketch the graph of fx over here. Okay, I'm going to make a rough sketch. So first of all, what we know the fact is that when the when x minus 2 is basically equated with 0, so x will be equals to 2. So the function would be undefined over here. Okay, so this essentially means that x is equals to 2 is a vertical asymptote. First of all, we have identified what is the vertical asymptote over here. So x is equals to 2 is the line of the vertical asymptote. And the second thing is that when output of the function fx is kept, equals to 2. Okay, so when fx is basically kept equals to 2, so I'm going to say that 8 over x minus 2 plus 2, this whole thing is equal to 2. So 2 and 2 are cancelled out, and simply 8 over x minus 2 will be equal to 0, meaning x minus 2 will be equal to 8 over 0, and this means that x will be undefined. So x is undefined when fx is kept equals to 2. This essentially means that the line which has the equation y is equals to 2 is the horizontal asymptote over here. So this means that horizontal asymptote is y is equals to 2. As simple as that. Okay. And as you know this thing, as you can see over here in the function fx, that the constant which is above x minus 2 is a positive constant. Okay, so the shape of the graph would look something like this. So if there was not any restriction on the domain, so if I want to sketch the graph of fx without any restriction on the domain, so if you keep x is equal to 0 inside the function, okay, if you keep x is equal to 0 over here, so 8 divided by minus 2 plus 2, which means minus 4 plus 2, which is minus 2. So this minus 2 is basically the y-intercept over here. So let's say if there was not any restriction on the domain of fx, the graph would completely look something like this, where the y-intercept would be minus 2. However, the domain which is restricted in the question is that x is greater than 2. Okay, so what I'm going to do, I'm going to only keep the graph for the required domain, that x is above 2. All right. So as we can see that according to this graph, the whole graph is completely above the horizontal asymptote, meaning the range of fx would be fx is greater than 2. And there is no upper bound on the range of fx. So therefore, the answer for part A is that the range of fx is that fx is greater than 2. This is the range of fx. In this way, we have identified the range of the function f. All right. So now let's move on to part B. Part B says that state the range of the function g. As we already know this thing that fx and gx both have the same functions. Okay. But gx is another function which is having a different domain, which is x is greater than 2 and less than 4. However, both functions are having the same expression over here. So what I'm going to do, I'm going to sketch the graph of gx in the same way. This was the graph of part A, which was the graph of the fx function. And now I'm going to sketch the graph of the gx function over here. So I'm going to sketch the graph of the gx function over here. And since the expression is same, so x is equals to 2 and y is equals to 2 would be the asymptotes. X is equals to 2 is the vertical asymptote and y is equals to 2 is the horizontal asymptote. Okay. So the domain for gx function is that x is greater than 2, less than 4. Okay, so we need to observe when we keep x is equals to 4 as the input of the function, what is the corresponding output of this function? Okay, so 8 divided by 4 minus 2 and then plus 2. Okay, so 8 divided by 4 minus 2 and then plus 2, which means 8 over 2 plus 2, which means 4 plus 2 is 6. Okay, so the output over here is basically 6. So I'm going to sketch the graph for this restricted domain that x is between 2 and 4 exclusive. Okay, and now according to our sketch of the graph of gx, this is the graph of gx. Okay, so accordingly with this sketch we can see that the complete graph is above the value 6. It is more than the value 6. Okay, and since x is equals to 4 is not included in the domain, so gx is equals to 6 is not included in the range. Therefore, we are going to say that the range of the gx function is that gx is greater than 6. Okay, so the range of the function g is that gx is greater than 6. In order to find the range of any function, always helpful to sketch the graph. Okay, so this was the answer for part B. So now let's move on to part C. Part C says that state the range of the function fg. Okay, the composite function fgx. So what you know the fact is that the composite function fgx would exist when the range of g is contained within the domain of f, meaning the range of the function g will become the input for the function f. And as we have already seen that the range of the function g is that gx is greater than 6. So for the fgx function, I'm going to sketch the graph of fx. I'm going to sketch the graph of fx for the domain x is greater than 6. Okay, because the range of g will become the domain of the function f. G is the inner function, okay, and f is the outer function. So again, the same expression, but the domain is that x is greater than 6. So I'm going to sketch the graph of fx, meaning I'm going to sketch the graph of the outer function for the domain x is greater than 6. So first of all, x is equals to 2 is a vertical asymptote and y is equals to 2 is a horizontal asymptote. Okay, and now the domain is that x is greater than 6. Okay, so we need to see when the input of the function is x is equals to 6, what is the output? Okay, so we are going to see what is the output over here. So 8 divided by 6 minus 2 plus 2, meaning 8 over 4. 8 over 4 plus 2, meaning 2 plus 2, which is 4. Okay, so this means that when the input of the function is 6, so output is basically 4. All right, and the domain is that x is greater than 6. So the graph would look something like this. Okay, for the values of x which are above 6. Okay, so according to this sketch of the graph, what we can see over here is that we can see that, the range is basically above 2 but below 4. According to the sketch of the graph, we can say that the range of the outer function f is now fx is greater than 2 but below 4. Now the range of this outer function will become the range of the component function fgx. So therefore we are going to say that the range of fgx is that fgx, the range of fgx is that fgx is greater than 2, less than 4. This is supposed to be our answer to part C. Okay, the range of the outer function will become the range of the composite function. Outer function is f, inner function is g. So part C answer is that fgx is greater than 2, fgx is more than 2 and below 4. All right, so this was part C. Now part 2 says that explain why the function gf cannot be formed. Okay, so what you know the fact is that The condition for the composite function to exist, the condition is that if you are considering this GF composition, so the range of f must be contained within the domain of G. Okay, here we have a basic rule. I mean, if I say that for GF to exist, for GF to exist, the rule is that the range of f must be contained within the domain of G. If this condition is being fulfilled, then the composite function GF would exist, otherwise not. So first of all, what we are going to do, we are going to observe the range of fx. As we know the fact that, the range of fx is that fx is greater than 2. Okay. However, the domain for G, which is given to you in the question, is that x is between 2 and 4 exclusive. The domain for the gx function is that x is greater than 2, less than 4. Okay, so the fx function says that my outputs are more than 2. Okay, but the gx function says that I only take inputs which are between 2 and 4 exclusive. So this means that there is not a complete understanding between these two functions. Let's say fx produces an output. Let's say fx is equals to 8. Okay, so the function f says to G that 8 is my output. Please take this as your input. But G says, no, brother, wait. We have a restriction on our inputs that x is between 2 and 4. So we cannot keep fx is equals to 8 as input for ourselves. Just keep it with yourself. Okay, so this is basically the whole scenario over here. So as an answer, what we are going to say that either we can say that the range of f is partly outside the domain of G, or we can make some equivalent statements. As an answer, we can just mention that the range, we can mention that the range of f is partly outside the domain of G. Okay. Otherwise, you can also make an equivalent statement like this, that the range of f is not contained completely within the domain of G. Range of f, range of f is not contained completely within the domain of G. Or you can make any other equivalent statement over here. Okay, and for this reason, GF is not existing. All right, so here we had part 2. Okay, so now let's move on to part 3. Okay, it says that find the set of the values of x which is satisfying the inequality 6 times f dash x plus 2 times f inverse x minus 5 is less than 0. All right, this part is worth 6 marks. So I'm going to bring the picture of the question on the next page so we can attempt this part over here. Okay, so we have this inequality. First of all, we want to find f dash x, and then we have to find f inverse as well, okay, in order to solve this inequality. So this part is also including the concept of the topic, differentiation. Okay, so fx function is that 8 over x minus 2 plus 2, which means that fx is equals to 8 times x minus 2 whole thing raised to the power of minus 1 and then plus 2. So I'm going to differentiate fx function by using the concept of chain rule. So f dash x will be equals to 8 times minus 1 multiplied by x minus 2 whole thing raised to the power of minus 2 into 1, and then when this constant term 2 is differentiated, this will become 0. So therefore, I'm going to say that f dash x is equals to minus 8 divided by x minus 2 whole squared. This is your f dash x function. And now I'm going to find the f inverse x function as well. So for that purpose, first step is that y is kept equals to fx. So y is equals to 8 over x minus 2 plus 2. So I'm going to say that y minus 2 is equals to 8 divided by x minus 2. So x minus 2 is equals to 8 divided by y minus 2. And when we make x a subject, so x will be equals to 8 over y minus 2 and then plus 2. And in place of x, I'm going to write f inverse x. And in place of y, I'm going to write x. So 8 over x minus 2 plus 2. So in this particular case, the original function is equivalent to the inverse function. So this is the concept of the self-inverse. All right. So f inverse x is equals to 8 over x minus 2 plus 2. So what we need to do, we need to solve this inequality over here. So 6 times f dash x plus 2 times f inverse x minus 5 is below 0. So I'm going to say that 6 times minus 8 over x minus 2 whole squared plus 2 times 8 over x minus 2 plus 2 and then minus 5, and this whole thing is less than 0. So now in the next step we are going to say that minus 48 divided by x minus 2 whole squared plus 16 over x minus 2 and then plus 4 minus 5, and this whole thing is less than 0. Okay, so far we have achieved this thing. So now we are going to say that minus 48 over x minus 2 whole squared plus 16 over x minus 2 minus 1, and this whole thing is below 0. So now what we can do over here is that we can multiply this x minus 2 whole square on both sides in order to eliminate it from the denominators. Okay, so I'm going to perform a step that multiply x minus 2 whole square, okay, on both sides. So this means that this will give you minus 48 plus 16 times x minus 2 minus 1 times x minus 2 whole square, and this whole thing is less than 0. So now we are going to expand this. So minus 48 plus 16x minus 32 minus 1 times what? The expansion of x minus 2 whole square. So x square minus 4x plus 4. All right. So this means that minus x square plus 4x minus 4. Okay. And minus 48 plus 16x minus 32. And this whole thing is less than 0. So far we have achieved this thing. So when we simplify the terms, what we get is minus x square plus 20x and then minus 4 minus 48 minus 32. So what's the value? Minus 4 minus 48 minus 32. This is minus 84. Okay. And now we need to solve this quadratic inequality. And for that purpose, I'm going to take minus 1 as common. Okay. So taking minus 1 as common, multiplied by x square minus 20x plus 84. Okay. And when this minus 1 is gone on the other side of the inequality, so the sign of the inequality will change. So I'm going to say that I need to solve this quadratic inequality x square minus 20x plus 84 is greater than 0. All right. So far we have achieved this thing. So if we do factorization, so after addition we need to get minus 20. So x square minus 6x minus 14x plus 84 is greater than 0. So taking x common multiplied by x minus 6, taking minus 14 as common multiplied by x minus 6, and this whole thing is greater than 0. So therefore x minus 6 multiplied by x minus 14, this is the fully factorized form, and this whole thing is greater than 0. So I'm going to equate both of the factors with 0. So x minus 6 is equal to 0 and x is equal to 6. And in the same way, x minus 14 is equated with 0. So x is equals to 14. These are the critical values of x. Okay, because we are solving a quadratic inequality over here. So these are the critical values of x. So we are going to locate them. In order to solve the quadratic inequalities, always you need to sketch the quadratic graph. Okay, so x is equals to 6 and x is equals to 14. And since we know the fact that the coefficient of x square is positive, so the quadratic graph would be a U-shaped quadratic graph, meaning the least turning point quadratic graph. And the inequality is now in this form that it is greater than 0, meaning the region which is above the horizontal axis, above the x-axis, meaning the region which is bounded by the quadratic graph and the x-axis. Or you can simply say that the part of the quadratic graph which is above the x-axis. So I'm going to mark this part of the graph with blue pen. So according to our shading, marking, observation, what we can say that the solution of this particular quadratic inequality is that x is below 6, comma x is above 14. X is less than 6, comma x is greater than 14. However, what we know the fact is that when we are solving this inequality, so in the inequality, you can see that f inverse x function is involved. Okay, so we need to consider the domain of the f inverse function as well. Now, as we know the fact that, the range of the fx function was that fx is more than 2. So it means that the domain of f inverse x function is that x is greater than 2. All right. So we are going to consider this domain over here. All right. So according to the inequality which we have solved over here, x is below 6, comma x is above 14, but the restriction on the domain of the inverse function would also remain. Okay. So our final answer will be according to the domain of the inverse function. Since the original inequality is considering the f inverse x function and also f prime x, meaning the derivative of fx function. All right, so the domain of the original function fx would also be considered, which is also the same, which is x is above 2. So due to these reasons, what we are going to do, we are going to say that our answer is like this: x is more than 2 but below 6, comma x is above 14. X is greater than 2, less than 6, comma x is greater than 14. This will be your answer. All right, we need to consider the domain of the inverse function as well. All right, so this was basically the question number 33 of this handout, which was February-March 2018, paper 1 variant 2, question number 10. All right, so in this video, I've discussed 3 past paper questions. So inshallah, in my next video, I'll be discussing some more questions. So stay tuned to my channel. If you like my content, do share it with your friends and do subscribe to my channel. Thanks for watching. Assalamu alaikum.